Next talk is by Dr. Rob Pace, past president of IEEE Standards Association. So Rob, besides being IEEE leader, he also has been a great mentor personally for me. When I was like a young IEEE volunteer trying to help, I got a lot of guidance from Henning, no doubt about that. But on the professional level, Rob has been a great champion. He, in fact, encouraged me to stand up these IEEE future networks. And at some point, I just have to make it open. At some point, I was not able to do that, and I just took a leave of absence for that. Rob was the caretaker for that position for 6 months. Then when I was able to take it back, he gave it back to me. So I think I really appreciate the caring and how to nurture.
Taking it back.
Thank you for giving me. Okay. Anyway, so I think we have a big bio here, but obviously he's a professor at Princeton, 17 patents, past president of IEEE Standards Association. He also is an entrepreneur. He was at Bellcore before, Panasonic Research, head of Panasonic Research in Princeton. He has a Ph.D. from Stanford, and he's been involved in many standards activities. I think the previous speaker talked about that. Maybe Rob can say a little bit more about that. And he has also Standards Medallion, IEEE Standards Association, with a fellow of IEEE as well. Thank you, Rob. With that, I'll give you time to talk. Thanks. Nice, thanks.
With the picture in front of you. Can everyone hear me?
Yes.
Okay, great. Hit the buttons. Okay, I'll hit the buttons. Okay. So thanks so much for that introduction. Slightly embarrassing. So today what I'm going to talk about is connecting. This theme today is connecting the unconnected, but what I really want to do is connect the unconnected to the IEEE Standards Association. And so I want to say a few words about that. Okay, so what's a standard? We just heard some desire for some standards. Standards usually go through a life cycle. Sometimes they start out as something quite unofficial. For instance, the IEEE Standards Association has a standard for their slides. And this is the standard with a black background with white letters, which the standard of which is not always adhered to. But after a period of time, the standards essentially get regularized, normalized, and sometimes adopted by more as a specification. Just to give you an example, one of the oldest technical standards that I know of is about 3 centuries old now, maybe 2.5, which is with the gauge of the railroads in England and the US and most of the world. It's called, not surprisingly, standard gauge. Is 4 feet 8 1/2 inches. In metric countries, that's shown in millimeters, but that's what it actually is. Now, where did this come from? Well, sometime in the 18th century, England had just started to dig a lot of coal out of the ground. And when they dug the coal out of the ground, they had to put it in carts. And those carts had to be hauled over ground to wherever they were going to use the coal. But if you haul heavy coal carts over the ground, it creates ruts in the road. So they, instead of having the carts getting stuck in the mud all the time, they started putting down planks of wood. And these planks of wood were about 5 feet apart. But the boards themselves were about 4 inches or a little bit more than that. And so for a period of time, they were just hauling carts over these roads. By the way, the 5 feet came from the fact that coal carts were heavy and you needed 2 horses to pull them. So they put 2 horses next to each other, and 5 feet is about the distance that you need for 2 horses. So so this went on for a while, and then when the first it became obvious that you could mate steam to pulling things as opposed to horses, the engineer who designed the first locomotives, Stevenson, said, okay, well, 5 feet apart, let's stick the metal part, the iron part on top of that. So he actually built the first locomotives so that they ran on the distance between these two boards, now with a piece of iron on it. And then they discovered curves in the road. And so when you railroad goes around a curve, it kind of the carriages have to sort of tilt a little bit. So they added the extra ½ inch. And so that's where it became 4 feet, 8 1/2 inches. And that's actually the global standard today. It wasn't regularized until the middle of the 19th century by the an act from Parliament in England called the Gauge Commission or the Gauge Act. And so there we had an example of a standard that started out as an informal, customary kind of adaptation, and then wound up becoming an almost global standard. And we see this sort of thing today in many places. Standards evolve over time. So this is a graph of one of the IEEE standards. This is our 802.11 series of standards. You're using Wi-Fi in the room, so Wi-Fi runs on an IEEE standard called 802.11. IEEE is great at coming up with technical things. We're not that great at coming up with names. So of course we name our standards with numbers, which makes them eminently forgettable, but we can call it Wi-Fi. And so you can see over a period of 25 years that this standard 802.11 has evolved from about 11 or 10 or 11 megabits per second to 10 gigabits per second, backward compatible the whole way. So it's really been an achievement. And Wi-Fi is in fact one of the key elements of creating connectivity for the unconnected, because it runs on ISM bands, free spectrum basically, so that people aren't paying for it and therefore carriers aren't paying for it, therefore you're not paying for it. And no one's paying for it in this room, I don't think. Standards are interesting because they interact with other phases of technology development. Often we see these sort of linear developments of this sort of conceptual phase of technology and pre-competitive, competitive, and deployment. Actually, things don't work that simply. There's always a feedback loop. Particularly in standards, many standards meetings you go to, you see a bunch of people sitting in the back of the room taking notes, and you know what they're doing is that they're writing the sketch for their next patent. So they're trying to elaborate on the standard even as it's being created to incorporate some new technology. IEEE is a little bit different in terms of a place to develop standards and why it's particularly adaptable to a subject like connecting the unconnected. So IEEE is interesting in the sense that we both have many technical societies that actually develop technical literature and cutting-edge research, but we have a very broad scope everywhere from oceanic engineering to ferromagnetics to more typical sorts of electrical engineering and computer science. We also have membership that's both individual and corporate, and we represent a variety of kinds of things in terms of scope and in terms of the expertise. So we do have lawyers, for instance, in IEEE. Not a lot of them, but we have some lawyers and policy people as well. Now, here's what I think is really key for connecting the unconnected is that unlike many standards organizations, so if you go to, for instance, the Geneva-based International Telecommunications Union, it develops standards, but ITU is a body of the UN, and the UN is a country-based system, so you need to go through the country to get yourself nominated in ITU. It's not, so if you're not a country, and most of us in this room aren't countries, then that's a difficult place for you to start doing standards development. IEEE, on the other hand, does both individual standards, so that means that just any old body, like any of you bodies, can go and come to me or many other people and say, we have an idea for a standard, we can grow a community around that, and we'll accept you just the way you are. 802.11 or 802 in general, although it is a global Wi-Fi and Ethernet and LAN standard, is based on the individual method. So although there are many companies that send bunches of people there, actually the voting system is one person, one technical expert at a time. IEEE does have another method of standards development called the entity method, and that's a method in which basically it's one vote per company or entity or university or things like that. And it depends, you have a choice. You can do it either way. The entity method is much more conducive to situations where already there's been sort of a corporate structure imposed on some technical standard, and the companies want to decide among themselves what they're going to do. The interesting thing about it is that why do people do these standards, whether it's individuals or corporates? And the basic answer is that when you develop a standard, you increase the market. And if you can increase the market, then that makes it economically more viable for entities and for people to do that. And so connecting the unconnected is an obvious situation where large service providers and equipment providers don't find it that economically viable to serve you, to serve those unconnected communities. But coming together to do a standard and making that standard publicly available for nominal cost for free, which is certainly possible, then that market can grow in a way that is otherwise unobtainable. Yeah, and so there's a set of rules here about how you go about going through the standards process, and I'll talk more about those in a moment here. So what are the methodologies, what are the aspects of standards development that we develop? Certainly we allow direct participation, so you don't have to go through an entity. There's due process, broad consensus. So typically for an IEEE standard, what we require is not 100% consensus, but about 75% is what we'll get an IEEE standard adopted. We require balance, so we don't like what's called dominance. So like one company comes in and says, we're going to do a standard. We want a variety of people from a variety of public, private entities to come in and provide feedback on standards. We like standards more or less to be coherent in the sense that they take advantage of the latest technology and interoperate well, although that's not always the case. There's a development dimension. Development here means countries that are in a more less developed situation, so we want to include that. And everything about the IEEE process is transparent. So all contributions are made publicly. They result in something that's widely available. Okay, so what are the things that the standards do? It ensures system interoperability. It creates new markets, which I think is really important for connecting the unconnected, and have better cost efficiency, reducing market risk. These are all related. Improve reliability, enhance and provide a mechanism to continue to enhance technology. So as we saw, something like 802.11 just went over a 20 or now, I guess maybe 30-year reign of continuous improvement in the technology with continuing change of cast, but of people working on it, some of whom were the same, some of whom were different over time. So the SA provides a variety of services that help make a standard go. So we actually could help you incubate it. That's what our industry connections do. We can manage the alliance if that's what you want to do. We provide conformity assessment standards. We do open source. We have registries. So like registries. What is a registry? A registry is a number. So for instance, every one of you who has a laptop or a phone here has a specific number that's associated with it that tells it its address on the local network, those numbers are handed out by IEEE. And then we can provide training and development associated with the adoption of this. As I mentioned, one of the great things about IEEE is the broad spectrum of technologies that we offer, not only standards, but in technology as well. So here we go from A to S, from aerospace electronics to socio-technical standards and everything in between. And if you have an idea, come to us, we'll make it something we can work on. It is interesting, and I think we see here in the unconnected space is that actually participating in standards and the dynamics of that is complex. It's not just the technology. I can't tell you how many times somebody has burned my ear about how they had a much better technology than Wi-Fi or you name it. But it was those other guys who didn't let it be adopted. There's complications there, and I don't want to underemphasize those. So there's technology, there's economics, there's politics, politics written large at country level, politics written small at an intercompany level. But persistence in terms of actually staying in there through the whole process. And typically a standard can take anywhere from 1 to 4 years to actually make it through the whole process and get adopted. Depends on how much controversy there is and how many ballots you have to go through and recirculation and a variety of things like that. But you can get it done if you stick with it. One of the interesting things that we've started in the last few years is that IEEE will never be a situation where we allow governments to dictate the work that we're doing, but we can allow governments to come and send representatives and participate in hearing what's going on. And so we started this program called GEPS. So we have about 37 countries. So it's a lot fewer than the United Nations, but still a lot of countries who decided to send representatives to some of our standards. Finally, of course, it is possible for a country, once an IEEE standard is promulgated, to adopt it as a matter of national policy. And we've seen that occur. And sometimes runs into problems because different countries might want to adopt things differently. But anyway, we have seen examples of IEEE standards becoming local regulation, in essence, in various countries. One of the things that we do that quite a bit recently is trying to work with standards that have social impact, and certainly connecting the unconnected is an example of that. So we have some work on ethical AI, data governance meaning who's allowed to move what data where and things like that. Fairness, online child rights, a very interesting set of work in that way. Sustainable and clean energy, connectivity and mobility. So all of these are elements not only of the technology for connecting the unconnected, but also of its use and adoption. And I think we're very open to working in that. These are just some examples of standards for connecting the unconnected in IEEE. It's just a sampling here. So I'll just read the titles here because it's too much print and it's too small. Recommended practice for internet grades of service in rural areas. That's one of them, P1941.1. You'll notice that really snappy number there. Standard for providing broadband connectivity to rural infrastructure by utilizing solar panels as optical communication receivers. So that's kind of interesting, right? So an idea that if they're going solar, maybe we can use the panels themselves in a communications network. Architecture for low mobility. Low mobility means almost stationary. Energy efficient network for affordable broadband access. So sometimes we call this frugal 5G. So 5G for cheap people. But not just communication standards. So IEEE 2030. This is a huge standard that came out of primarily the Power and Engineering Society. DC microgrids for rural and remote electricity access applications. So being able to build a microgrid in a distributed fashion. And then wireless regional area networks for TV white spaces. So particularly as digital broadcast TV has made available a bunch of spectrum that isn't underutilized and so it could be reutilized because it's very good spectrum. It's very it's good at going over long distances because it was built for TV. So maybe we can utilize that as well. Okay, so I'm gonna wrap up there. I don't know how I did on time, but I was trying to make a little bit of time.
Sure. I wanted to, the RRSA part, you want to say a little bit about that? The one you created?
Sure. Okay, so when, the question is, what kind of processes can we create within IEEE to facilitate perhaps non-customary contributors to standards? It's very easy for engineers who do this all the time to do it, but is there a way that we can get researchers and other people who are doing it? So we came up with a strategy for, we refer to it as RRSA. I think I named it that, Rapid Reaction Standardization Activity, RRSA. And what that allows is essentially a pre-standardization activity where people gather in a room like this, and they may do some brainstorming, and people with crazy ideas or maybe not so crazy ideas can come up and try to gather some groups to do that. And that's been a very successful way for us to start standardization activities with groups of people who are not customarily involved with that. And I guess at this point, I'll take any other questions.
So I think, sake of time,